Hi everyone and welcome to the new video. Today we will make a small IoT project just for fun, and I will show how to play music using ESP32 and Bluetooth Tesla coil. We will be using Bluetooth and ESP32, no soldering will be required, and after making this small weekend project you will be able to play something like this. This musical Tesla coil is available on Amazon as an educational toy. It is safe and you can even touch these sparks. And even if you don't have a Tesla coil, you can use a standard Bluetooth speaker for testing. Also, if you don't want to program anything, I will show how to connect this Tesla coil to your phone and play music through it. It can be fun. Without further ado, let's get started. As a first step, let's see how the Tesla coil works. Tesla coil is an interesting device. It's a high voltage resonance transformer. It was invented by Nikola Tesla in 1891. As I mentioned before, the Tesla coil I will use is available on Amazon as an educational toy. It's pretty cheap and it's easily available. The Tesla coil is generating high voltage so it can produce long sparks, but the current is low and the high frequency current does not penetrate the skin, so it is safe to touch. As you can see, I'm doing this now and I feel practically nothing, only a bit of warmth. It's absolutely not painful. Interestingly, the Tesla coil is also generating a high intensity electromagnetic field, and if you have a small object like this lamp, it can glow in your hand, which is also fun. And if you occasionally have a glass bowl with a noble gas in it, you can see a nice glow. This Tesla coil can work in two modes. The first mode is autonomous. Here you can set the power and the frequency. It does not need any connection, you just turn these knobs and it works. It is pretty loud, so I am not turning it on for a long time. I don't want to disturb my neighbors. And the second mode is a Bluetooth mode. In this mode, the Tesla coil is available as a Bluetooth speaker. So if you don't want to program anything, you can just open your phone, search for Bluetooth devices and connect it, and then you can play music. Obviously, the Tesla coil is not a high-fidelity sound source. First, you need to set the volume to maximum, otherwise there will be no spark. And second, the best results can be obtained with 8-bit music from old games like simple square or sine waves. I can open YouTube on my phone and play something now. As we can see, it works, but playing music on your phone is not the purpose of this video. And now I will show how to program the Bluetooth audio on the ESP32. And as I mentioned before, even if you don't have a Tesla coil, for debugging you can use any Bluetooth speaker, so it should be easy. Without further ado, let's get into it. Okay, now let's start with coding. For this project I will be using Arduino IDE. In my previous project I used Python, but MicroPython is not powerful enough for ESP32, it's not too fast. Python is not fast enough to handle audio processing, so I will be using C++ and Arduino IDE and I will show how it works. Let's get started. As I mentioned before, for the Tesla coil it works better with the sine or square wave, and for this project I will be using open source A2DP library. The page is available on the screen. At first I will open the example from this library and I will explain how it works. As we can see, first the header file is included, then we have an audio source object. This object will be used to create a Bluetooth connection, and the next important method is getDataFrame. This function will be called automatically and our task here is to fill the data. As we can see here, the sine wave is generating. The code is pretty easy. We have an amplitude and we have a sine wave and we have an angle. And when this callback generated, this buffer is filled with the sine wave data. Here we can see two another interesting method. One is SSID callback. For this we can check which devices are available. For example, if I connect my Bluetooth speaker, I can see this SSID here. The second important callback is connection state changed. It's not so critical for actual run it, but it's good for debugging. Sometimes the Bluetooth is not connecting and we need to reconnect the power, so with this callback we can easily see the status. And we can see the main code is simple. In the loop here is nothing, this is only a delay. And in the setup we create the sound source, we set the callbacks, we set volume and we press start, and the library is doing all other job for us, so it's pretty convenient. Now let's connect the ESP32 and see how it works. I can compile the project and upload it to the ESP32. If you want to buy your own board, please check first the description of this library. Not all boards are compatible and not all boards have a Bluetooth audio support. And now I'm turning on my Bluetooth speaker. Alas, as we can see, it does not work well. I can definitely hear that the sound is choppy, and I think that this ESP32 is just not fast enough to generate sine waves with the proper speed. As the first step, I will improve this, and then I will show how to play the music. Okay, as the first step, we need to optimize the code. As you can see in the source code, we use a sine function, which is pretty slow on the ESP32. As the first step, I will switch from using time to using phase and angle. I will add these variables. I will use an angle as a global variable. This is the frequency that we will play, and this is the degree in angle that we will increase. It will allow us to generate the sine wave. Our sound buffer needs integer values, so I will create this method. As we can see, I just generate sine wave from the table, from the angle. It's pretty easy. I generated this table using 5 lines of Python code. I will also add a set frequency method that will set the frequency I want to play, because it will be important later for the music. And our generate frame method will be much shorter now. As we can see, I'm just getting the sine from the table, and the angle should be smaller than 360 degrees. So when it is larger, I decrease this, and technically that is it. So here I switched from the floating point values to the integer values. I don't need to multiply floats anymore. In the main loop, I will add the callback to verify that the audio is connected, because if it's not connected, there is nothing to play. And when the Bluetooth is connected and it's ready, I will just play this frequency, so let's see how it works. I'm turning on my Bluetooth speaker. Well, this is much better and this part works. Let's go forward. Okay, at this point we can generate a sine wave, and now we're ready to play real music. For this part of this project, I will use this nice GitHub library, Arduino Songs. It is open source and it's available on GitHub. It is a pretty old project and it was created for Arduino. As we can see, it's 6 years old, but technically it works. We don't need this connection anymore, but songs itself can be reused. For example, let's open the Merry Christmas song. First I will copy the notes definition in the project, because I will reuse it. As we can see in the original project, one file is one melody, so I will update this a bit. First I will create a structure melody. It will contain a song name, it will contain a tempo and a list of notes. And this is the example of how can we use it. This is the original file. For example, this is the song Silent Night. It has a tempo, it has obviously a name and a list of notes. This way I can create a list that is easily expandable. Here is an example. I added a second song from Super Mario that you heard in the beginning of the video. The author of this library is using the simple notation. He is using a note and the duration, so we will need to split it into parts. I will show now how to do this. First, let's see that nothing is broken. As the next step, I will add the method play melody. I copy it from the library without practically any changes. I only added printing the name to the serial port, so it's easy to see which melody is playing. It's good for debugging. As I mentioned before, the first value is the frequency, the second value is the duration. The author is using this type of notation. If the duration is negative, it is longer, so I keep it as is. I also added the check. If the connection is lost, I break the cycle, because there is no need to play. For debugging, it is also nice to have output in the console. And that for every node, I set the frequency and I set the delay, and the callback automatically will pick up this new frequency. And as the last part of the code, instead of playing one frequency, I will iterate through the list of my songs. So I iterate through this array, and I have an object of type melody, which is this one. And also there is a check that the connection is not lost, and that's it. Let's upload the code and play it. The same way as before, first I will use my Bluetooth speakers for testing, and as a final test I can test with a real Tesla coil. The Tesla coil needs a high volume, so I will change it to a higher value. While I was doing this project, it became dark outside, so it's nice time to connect the Tesla coil. Let's see how it works. As we can see, we can hear the music, everything works well. Viewers who wish can get the source code on my Patreon page. This support helps me to buy devices like these for testing. In the next project, I will investigate audio capabilities of ESP32 in more details, and later we can make a music instrument like stylophone, so it can be fun as well. I hope you enjoyed this video. It is a fun weekend project that you can easily do. Don't forget to like this video and subscribe if you like it, and see you next time. Thanks for watching.